So first you have to create a folder, and this time I'm going to call swap token, and let's open this particular folder in your VS Code. So let's open your VS, go to the open and go to the desktop, and I have to select the folder. So this is the one I have created. Now the very first thing you have to do is you have to get the starter file for the project, and which is already provided to you on the blockchain coder. So all you have to do is to come back, open a new tab and open the blockchain coder. Here you will find all the resources, all the project which we have built so far on our channel, or you can check this particular course which I have launched, full stack NFT marketplace course, which controlled by totally smart contracts. So you can come and you can have a look at what exactly you're going to build. Just play this video and check out the modules that what you're going to learn. So this will teach you every single technology which you have to know as a blockchain developer. So make sure to come and check. Now come back here, go to the source code section. And from here you can download the starter file which we can start coding together. So here you will find all the project we have built on our channel. So make sure to come and have a look at what you have to learn, what you have to build, because we have a variety of project. Now you can do this, you can simply filter this recent project, and here you will find that the project we're going to build. So make sure to click on this get now, and here you will find the complete code and the starter file. So if you want to buy, you can buy it, but we're going to code everything from scratch. So click on the starter file, and we're going to copy this entire repository. So you can find all the structure which I have already predefined. So simply click on this URL and copy the URL and come back to your VS Code. Here we are, make on the big screen. Now open up your terminal. So let me simply drag on this. Let's open the terminal and we have to clone the repository. In that I have provided all the starter file, all the images, all the CSS, all the libraries we are using, including the packages. So make sure no matter when you are watching this project, you have to follow the exact step for doing the setup. So first thing you have to do is type git clone, and we have to clone the repository and give this dot. So this will clone the repository in the same folder. Hit enter. It's going to take few seconds, and here we have cloned the entire repository. So first thing we have to simply delete this git. Now let me give you a quick walkthrough that what we going to build and what is the structure we're going to follow throughout this entire project. So we have this component. Inside that you will find all the components we're going to build together from scratch. So we have this feature, we have footer, we have header, hero, and here we have this index. So I have already imported all this component into a single file, and from here we are exporting so we can receive and utilize this component in our application wherever we want. So we have all of this. I have already done the import for all of you guys, so you don't need to do anything in here. This is the platform, payload, everything you will find here. So that's all we're going to code it together. So that's the component. Now let's look at the context, because there is some important things I have provided. So open this context. In that you will find we have this ABI. So this is the first ABI. It's a ERC20 ABI which we're going to use for getting the information and performing the swap. And here is the normal ABI, and this is the custom ABI which I have designed, which we can use. So we can use both the one, but I have given you both so you guys can do the experiment. So close this one. So here we are in the constant, and here I have provided two important account which we're going to use throughout the entire project. So the very first thing we have is this P3 swap router address, and this router address is very important no matter which network you are testing your application, whether it's a testnet, mainnet, it has the same address in all the networks. So we are using this particular router address to perform the swap. And here I have taken another account. So this is the real account on Ethereum network, and this account has a lot of funds. So it has close to 24 ether, which we're going to use it because we're going to perform the fork and we're going to do all the transaction on the mainnet, not on the testnet. So this address is very important, which has a lot of fun and all the token, so we can simply test our application. So this is what I have given to all of you guys. And now come back to the context. Here we're going to build all the context management, including the functionality. That's all we're going to code it here. Currently it's empty, so close this one. Now we have the pages. Inside that we have these two pages, app.js. Here I have already done the setup for the library. So we are using some internal library, and these libraries is also provided to you in the public folder. So open this one. Inside this assets, you will find all the libraries, all the CSS file which we using in this project. So if I open this one, in that you will find CSS, icon, images, and JavaScript. If you come back to the JavaScript, here you will find all the libraries, including the plugins which you are using for the slider and all. That's all is there. Inside that you will find all the thing. Got it? Here we have the bootstrap, jQuery, and main.js file. In that we're going to write some custom. So that looks good, and this is the plugin we have. So we have our JavaScript and we have successfully done the connection, means we have imported and connected with our application. So that's the setup I have already done, and this is the global CSS file which we have imported. So close this one. We are done with this app.js. Now come back to the index. And right now we have nothing in here. It's going to be a single page application. So we're going to call all the components right up here. Looks good. Now come back to the style. Let's go to the public. Inside the public, you will find that we have the images, all of that we have already seen. So come back here in the style. And here you will notice that I have imported all the CSS library which we are encoding, which we are utilizing for responsiveness, custom styling, animations, icon, bootstrap, normalize. That's all libraries you will find here. And that's coming from the public. So if you go to the CSS, there you will find all that. Looks good. And here I have written some custom CSS for just loader and few changes I want to add from my end. So that's all configuration I have done. You don't need to do anything. All you have to do is to simply call the classes, and which we're going to do it together. Now close this one, and here we have the unit test. So in this project, we're not going to write unit tests, but when you are working on a smart contract and building anything custom, it's very important that you have to perform that test. So the very first test we perform when we write the smart contract is the unit test. So we're not going to do that. So simply remove this one. Now we can come back to the utils. Inside that, we're going to build some utility function, one for getting an error. So if anything goes wrong in our application during the function call, so we have to catch that error and we have to display in the front end. So that's the logic we're going to build it here. So that's what we have. And here we have this configuration I have already done. So we're going to do all this transaction on the ForkNet, which is going to be Ethereum. That's the configuration I have doing. So we have this forking, and this is the RPC endpoint which I am using. You can go with the same one. There is no problem in that. Does look good. Now we can come back here in next.config. So you can leave it as it is. If you want to call any external libraries and you want to import any external data, then you have to do the configuration. But in this, we are not doing anything like that. Now the main thing is come back here, and no matter when you are watching this project, you have to install the exact version, because whatever transaction, whatever logic you're going to build, it's going to be dependent on this particular version. So here we have all the script, and here we have the packages. So we are using Nomic Foundation, Hardhat, Next.js, Toaster, and this is the Hardhat version I'm using. So this particular Hardhat is compatible with one specific node version. That's what I'm going to talk about. We have the Ether. We are using this particular Ether package. We have multiple, but we are using these two packages. And the rest of the packages are similarly the same. There will be changes in the version no matter when you are watching this project. But right now we have this particular version which is 100% compatible, which we're going to use it. Now close this one. Now we have seen all of this. Now we have to install all the libraries. So open up your terminal, and the very first thing you have to do is you have to check your node version. So type node-v. So right now Hardhat is compatible with this particular node version. So no matter when you are watching after 5 years, after 10 years, if you use exact node version, it's going to work absolutely fine, because recently there is a node 20 which is not that compatible with the Hardhat, and it's going to not allow you to install all the Hardhat packages as a whole. So it will install individually. So that's going to create a huge mess, and that's going to create some webpack error, which I'm not going to cover. That's a separate topic. So make sure to install the exact version and it will fine. So if you are higher version, make sure to downgrade it to 18, or if you are using the lower one, make sure to upgrade to 18. This will work fine. You can also check your, so this one is the compatible right now. You can also check your npx version. So this is the version I'm using, which is really fine. So make sure to do this particular check. Once you are okay with this, now we can simply install all the libraries. So clear your terminal and type npm I or install, both will work fine. And here you can see I'm getting this warning. It's telling me to upgrade. And the reason why I'm not upgrading my Hardhat package, because I have a couple of projects which is getting running and I have to do those unit tests, and I want to use Hardhat extensively. So that's why I'm not upgrading, but sooner I'm going to upgrade this. But for the time being, I'm going with this particular version. So here we have installed all the libraries, looks fine. Now clear your terminal. Now we can simply start the application. Type npm run dev. This will start the application on localhost 3000, and this is the command we have run. All you have to do is to simply copy this one and paste in your browser. So I'll come back, open a new tab and paste here, hit enter. And our application is working fine. So we have this index, means all the setups we have done so far, it looks absolutely great. Got it? Come back to the code, close this down, close this one. Now we can come back to the utils. And let's build out all those small functions which we're going to use it over and over again in our function. So let's work on the first. So let's build the utility function. So come back here. And the very first function we're going to build is called short address. So when we're going to get the data from the blockchain about the token, we don't want to display the entire address. It's going to mess our UI part. So we're going to make it short. So let's build that particular function. We'll say export const short 10 address, and in that we're going to receive address, and we have to simply make it short. So we'll take this template tutorial, we'll pass the address, we have to call the slice method, and we'll have to take the first 6 characters of the address, then we have to take the last. So we'll take this address slice, and that we have to pass the address dot length, and we have to simply subtract with 4. So we'll get the characters. So it looks fine. This is the simple short address function we have. So once you will pass the address, it's going to make a short and it will display fine. Now let's build the second function which is going to catch an error and is going to format the error in a readable format so we can display in the front end when the user will transfer and anything goes wrong. So let's build that particular function. So let's call export const and we'll call it parse error message. And then we have to simply pass the entire error object. So we'll say error, E stand for error. In that we call this, take a variable called JSON. We'll call the JSON.parse, and that we can pass this JSON.stringify, and in that we can simply pass our error. So we'll have our data. Now we have to simply return and format that. So we have the data in the JSON.reason, else we can go with the JSON error dot message. So make sure to give this question mark, because sometimes what happened that the data will take a little bit time, or sometimes the data is not there. So in that case, it will throw a component error. So it's better to put this to be on the safer side. And this is the only 2 function we have to add. This is the only 2 function we have to add. Hope you guys have written this 2 function. Now let's move to our context. So this looks fine. Now we can start working on our context. So before we start working on the context, let's work on the constants. So click on this. We have already these 2 address. Now what we're going to do is we're going to build a reusable model. So we need the reusable model for the Web3 provider because we want to make that connection with the MetaMask wallet, and we have to get the information about the user that who is connected. So let's convert that into a reusable model, and we have to also build a function which allow us to give the information about a token and some other information. So let's build that. So we can come back here. Let's do a couple of import. So first we have to import the Ether package, and we have to import the Ether package, not the package from Hardhat, because if you import the Hardhat Ether package, it's going to throw an error. So that's the thing we have to keep in mind. Now we have to import the Web3 model. So Web3 model, and that's coming from Web3 model. So a lot of you have told me that this particular package is depreciated, but as long as you use the exact version which I'm using in the project, it will work absolutely fine. Or you can build a custom model which allows you to connect with the blockchain, but I'm not going to cover that portion. Just go with this particular version and everything would be fine. Now we can come back here. Let's do a couple of internal import. First thing, we have to simply import the ERC20 ABI for the token, which I have already provided. So it's going to come from the same directory. So I'm going to take this one, ABI. So we have the ABI. Now we have to simply export it as a variable. So we'll say const ERC20 dash ABI to ERC20 ABI. So that's the one we have. So we got the ABI, we got the swap router address, looks fine. Now we can come back here and we have to build a function which allows to fetch the contract. So let's call that const fetch contract, token contract, and that we have to simply pass few things. We have to pass the signer or provider. Again, this particular function we are building is a reusable function. So all we have to do is to pass the address. Now we can come back here. We'll take this new ether.contract, and that we have to simply pass the address, then ABI, and the signer or provider. Let's call sign, because that's what we have call and receive. So this is our fetch contract function we have here. Now we can come back here. Let's call export const, and we have to build the function for Web3 provider. So we'll say Web3 provider. It's going to receive few things. It's going to be an async function, and in that we're not going to receive anything. All we have to do is to simply return the provider. So we'll take this try and catch, and we can simply console log out the entire error object, Once we have that one, now we can come back here. Let's take a variable and we can use our web3 package. So we'll say web3 model, and we already have that. So take this small. It's a new web3 model. So web3 model, what we have called, it's called web3 with small w. Copy. So that's what we have called with a small w. Copy, paste here. Okay, web3 model and call it. So it will have the entire web3 model object, and on that we can simply call the function. So let's call the connection function. So we'll call it connection, take a variable called connection, and we'll say web3 await web3 model dot connect. We have the connection. Now we have to simply build the provider. So that's very easy. We can take this new ether dot providers dot web3 providers. In that we have to simply pass the connection. So in that way we'll get our provider, and this particular provider is a dynamic one. You can go with the hard code, but this is the dynamic one. Now let's take the network, because we have to also pass down to our contract function in the Uniswap to know that which network the user have connected. So let's get that information, and this information is also available in the provider, so we can get that. So let's call this one network, and we'll say await provider dot get network. This will give you the entire object including the name and the chain ID, which we're going to utilize it. So we can come back here. Let's return the provider from here, provider, because that's the only thing we need. And what I can do is let's comment this one, because we are returning only provider, and this particular network we need in the token. So let's keep it like it. So this is our function for web3 provider. This looks fine. Now we have to build a function for connecting contract. So we'll say export cons connecting contract. It's gonna be an async. In that we have to receive the address, means the address of the token. That's what we have. Now we'll take a try and catch block, and we have to catch an error if anything goes wrong. There it is. Now we can come back here, and we have to do the same thing. We have to build the provider. So we can do one thing. We have already built the functionality for web3 provider, and I'm going to use this particular account because we're going to do the testing on the ForkNet. If I go with the normal account which we are getting from the web3 model, our transaction will not work because it has no fund. So we cannot able to do the testing. So I'm going to use this one. But when you will deploy, we have to simply provide the actual address of the user who connected with our application. So I'm going to paste here. So this is the address I'm going to use it. Now I can come back here. Let's take the provider. So if I come back here, we already have this and we are returning it. So we can simply call this provider. We'll say provider await web3 provider, call the function. We have the entire object of provider. Now we can come back here, and we have to get the network because this is the one which we need, and uncomment this. Let's format this one. So we got the provider, we got the network. Now we can come back here and let's build the functionality. So we'll take this variable const signer, which is available in the provider, called get signer. So this will give us the signer. Now we can simply come here and take the contract. So we already have built the functions. We'll say await fetch contract. So we can simply call the contract function, and in that we have to simply pass the signer because that's what we are receiving, and we have to pass the address because this particular function can receive multiple token. We are not going with the fixed token. We are going with multiple token. User can take USD or a lot of different token, the blockchain coder token. So they can add any token address and it will give the information. So we'll get the contract, and all we have to do is we have to simply format this particular data. So we'll take this user address because in the real world, when we'll deploy our application, we have to pass the user address, not the fixed address. Right now we are doing on the ForkNet, that's why we're going with the fixed address. But in the real world, we have passed the actual address of the user. So here we're going to take a variable called const user address. And this address is available in the signer. So we'll say signer.get address. So we have the address of the user. Now we can come back here. We'll take the balance. So we can check the balance of the user. So we'll say await contract.balance. And in that we have to simply pass the address of the user. So I'm going with the account which we have taken as a test, not going with this one. So what I will do is so let's keep it as it is. Now we can come back here And let's take a variable called name, because we have to get all the information about the contract, means the token. So let's call this symbol. We'll call it contract dot symbol. Then we have to get the supply. We have contract dot supply total supply. Then we can take a variable called decimal, await contract dot decimals. Then we can take a variable called address, and the address is available on contract dot address. So we have all this information about the token, which user passed the address to perform the swap and get the details. So we got all of these details. Now we can come back here and let's take it as an object. So we'll take a variable called token, and in that we can simply return as an object. So address, you can call address to be address. This will be the name. This will be the symbol. This will be the decimal. Then we have the supply ether, and we have to simply convert it. So we'll say format ether, in that we can pass the supply to string, and that's what we have here. Now we can simply replicate this and change this to, let's say, balance, and in that we can pass the balance of the user. So we'll say balance. So these are the data we are simply have in this token object. Now we can come back here. Let's take the chain. So let's call this chain ID, and we're going to test on the ForkNet. So I will go with the default one, and one stand for Ethereum, but we have to make it dynamic as well. So we will take it as an, let's comment this one. Let's call this one, I'll say chain ID, and we'll say name dot chain ID. So in this way we'll have the chain ID of the network connected, because all this information about the network we have in this network object. So for the time being, let's comment this one. Looks fine. We got that all information. Now we have to simply return that, return token, and that looks fine. And that's the only thing we have to do here in the constant. We have built our reusable model. So we have these two packages. We have the ABI, we have the ABI and the swap router. That looks fine. Now we have this fetch contract. This is the Web3 provider which we're going to use, and here we have the connecting contract. All we have to do is to pass the address of the token, and it will give us all the information. And we are using this particular test account. So what I will do is, this is the contract we are fetching, we are using that, and let's comment this one, because right now we are not utilizing. Comment this one. Looks fine. And that's the only thing. Come back here. Now we have to work on our context. Click here. Let's work on this particular one. We have to import couple of libraries. So first we have to import the React, and then we have to import use state, and that's the only thing we have to import. Now we have to simply import the, let's say, ether package. Once we have the ether package, after that we can simply import the toaster, which will allow us to display the error message. We can simply import the JSBI, and it's coming from JSBI. So this will allow us to simply handle the big number. Once we have this, now we have done the all import. Now we can simply import the Web3 model, and that's coming from Web3 model. Now we can come back. Let's call this internal import, and here we have to import the Uniswap package. So the first one is going to be the swap router, that's coming from the Uniswap. So we have to go to this particular one, and here we have to do the changes. Now it will come from, let's say, it's there in the router SDK. Then we have to import the trade. We have to import this trade type. Then we have to import this ether. Then we have to import this token and current currency, a currency amount. Then we have to pass the percentage. So these are the methods we are using. First, trade token, ether token, currency amount, and percentage. So these are the simple method we have. All we have to do is to pass the relevant information. So if we pass the name, symbol, decimal point, and the address, it will give us the entire object of the token. So these are the imports we have. It's coming from SDK core. Now we can come back here. Let's import the trade, and it's coming from V3 SDK. Let's turn this to 2, and in that we have to simply import it as a, let's say, V2 trade, because we have to import the V3 as well. So let's call this V2. Now we can come back here. Let's do the import. This will call pool. Then we have to import this nearest usable tick. Then we have this tick mat, and we have this tick spacing. Then we have the fee amount, and the last one is this trade, and we have to import it as a V3 trade, and that's coming from V3 SDK. And the last one is going to be the route, and we have to import it as a route V3. Hope so far things are clear to all of you guys what we have done. So we have imported all of these libraries, then we have doing the import of this Uniswap, all the methods from the library. So let's call this uni. Looks good. Here we have this SDK core, we have trade type ether, all of this looks good. Here we have this V2, and here we have the V3 SDK. In that we have got all this method. Looks fine. Now we can come back here and we have to import few more things. So we have to import the mixed route, and let's call this, and the method is mixed route trade. Yeah, that's the name we have. And this will come from a different location. So we have to get into this. Let's the router SDK, and we have to import the trade, and let's change this to router trade. There it is. Then we have to simply import the ABI of Uniswap V3 pool, and that's going to come from the same location. So we'll say Uniswap V3 core artifact, then we have to go into the contract. Inside the contract we have this Uniswap V3 pool. Inside that we have to get the ABI. So there it is. There is the ABI of this Uniswap V3 pool. That's the import of the Uniswap contracts and the libraries. Looks good. Now we can come here. Let's do the internal import, like the function we have built in that. Let's import that. So in this we can simply call it will come from the slash constant. In that we have to build this function. So we have to simply import this ERC20 ABI. Then we have to import the Web3 provider, and the last one is going to be connecting contract. So these are the 3 imports we are doing. Now we can simply come down here. Let's import the utils function, and that's coming from the utils. Say utils slash index. We need to get the short address, and we have to get the parse error message. So this is all the import we have done, including the libraries and some custom functions we have built. Now we have to work on the context. So we'll take this export const. Let's call this context, and we'll use this create context. Now we have to simply do the export. So we'll say export context provider, and in that we have to simply pass the children, make it return, and in that we're going to simply build all the function and the logic. So first thing, we have to simply take a variable. So we'll take this token swap, and this is going to be the name of our application. So that's why I've taken this variable. I'll call it token swap tab. You can literally call anything to your application. So that's the variable. Now we have to take a couple of use state, and here we have to call this loader, because we have to define the loader when the transaction is happening. Then we'll take another one, and this will be called address, and that we want to take this address of the user. We have to take another one, and this will be called chain ID. By default we'll go with no. Then we can come here and we can call this notification. So let's build the notification. So we are using this library, toaster library. So we'll call this one const notify error. It will take the callback function. So we'll pass the message toaster.error. We'll pass the message, and we have to set the duration, that how long we want to display the duration. So it's going to be 4 seconds. Replicate it, change this to success, and change the method as well. So change the method as well. This will be success. So this is the 2 component, one for error, one for success. Now we can come here. Let's build out the function connect wallet function. So when the user will click on the wallet connect, is going to open the MetaMask. Let's build that variable called connect. It's going to be an async. We'll take this try and catch and come back here. Here we have to build the condition. We'll say if window.ethereum is not exist, means there is no wallet available, then we have to throw the error message. We'll say return notify error, and in that we can simply pass this install MetaMask. If it exists, then we have to simply get the account. So we'll take this account and we'll say await window.ethereum, and we have to call this particular method request. In that we have to simply pass the method. This is the method we have available if we want to request. So we'll take this eth slash request account. So this particular method is going to trigger based on the click event. So there is a multiple option we have based on the user. When the user is opening your application, it will automatically trigger. So we have automated or we have a click event. So we are going with the click event. So it will give us the array of account because one user can hold multiple accounts, and that all will be available in the account object. So what I'm going to do is I'm going to take a specific one with the very first account which user is connected. So that's pretty easy. We have to check for condition. We'll say if account.length exists, then we have to take the very first account and we have to set in our state variable. So let's make it capital and copy and change it to capital. So we're getting the very first account. Else means there is no accounts, then we can simply notify the error that there is no account. We'll say sorry, you have no account. That's a simple logic we have. Once we satisfy this condition, now we can simply check one more time. This looks fine. We're checking for the window object, then we are checking for account, and on the base of that we are simply displaying information and setting in our state variable. Now we can come back here and let's get the chain ID. So we'll take this provider, we'll call our web3 provider, remove this one. We don't need this because we already built this particular one, web3 provider. It will give us the provider. If you come back here, and this is the function we are calling, it will return the provider, and in that we can simply call for the network object. So that's the provider I have. Now I can simply call this network. I'll say await provider dot get network. It will give me the network object, and from there I can get the chain ID. So let's call this chain ID and set this chain ID to our state variable. And that's the only thing you have to do here. And if anything goes wrong, we have to simply catch that. So let's come back here. We'll take this variable called error, and we're going to call our function which we have built called parse error message, and in that we have to simply pass the error object. It's going to give us the error message, and that's the message we have to display in our notification error. So simply pass it, and that looks fine. Or we can simply do the console logout so we can see in our browser that what exactly went wrong in our inspect element. So this is the entire function for connect wallet. So it will work absolutely fine. When the user will click, it will going to open the MetaMask and user can connect. So that's the very first function. Now we have to work on the second function which allows us to get the information about the token. So that's what we work on. Let's take a variable called load token data. It's will call load token. It's going to take the address of the token. We'll call it token. In that we're going to take this try and catch, and we have to simply open this one, and we have to get this copy and paste here, and all we have to do is to simply call the function we have built. So we'll take a variable called token details await, and we have this particular function called connecting token. In that we have to pass the token, means the address. It's going to return the entire detail. We're going to simply return it from here, and that's the only thing we have to do. So this is the best way you can keep your function more clean, because most of the reusable model you have simply abstract and keep in different file. Just remember that we have to write the entire code in this particular single function. It would be huge and very messy. I try to break down the application in multiple sub function to writing a clean code. So we done with this particular function. So this two function is look fine. Now we have to build a couple of internal function, and after that we're going to simply build our actual swap function, because our swap function is going to be quite huge. We have to get the information about the like swap options. We have to get the information about the pools and availability, liquidity. So we have to get a lot of details before actually we perform the swap. So let's write those internal function. So let's come back here and let's build the internal function for our application. So looks fine. Now what I'm going to call it, let's call it internal function is going to be an async function. We'll call it get pool, and on that we have to simply provide the information about the token. So we're going to pass the token A, token B, and we have to pass the fee amount, and then we have to simply pass the provider. So these are the three information we're going to provide. So it's going to return the information about the token. So we're going to come back here. Let's take a variable called token 0 and token 1, because this is what we call on the network. If you go and look at the documentation, so we have this token 0 and token 1. Now this data is coming from here, so we'll call this token A, because we are taking the very first token in account for performing the swap. So on that, we're going to simply call this particular method called sort b4. In that, we have to pass the token B address, and we have to check for a condition. So we'll take this, we'll say token A, token B, else we can go with the token B and token A, vice versa. So this is the check we are doing. Simple. Again, I'm not coming up with this. It's everything is there in the documentation. From there, I'm getting it. It was in the TypeScript. I'm just converting into a JavaScript. So what we are doing, we are getting the information about token 0 and token 1, and we are using this token A because it has this method, and even the token B has the same method, and we are checking for the connections, vice versa. So this will give us the information about the token 0 and token 1. Once we have that information, now we can come back here. We'll take a variable called pool address, and we already have the methods called pool. In that, we have to simply pass the token 1, token 2. We'll pass the fee, and this particular method, pool method, we have already imported from the packages. That's why we are calling it. So it will give us the address of the pool. Once we have the address, we can simply pass to the contract. So we'll take this contract name and we'll call it ether contract. We'll pass the pool address, the ABI, and the provider. And this is how we can get the contract. So once we have the contract, now we can come back here. We have to simply take a variable called liquidity. We'll say await contract dot liquidity function. This will give me the liquidity. Now once we have the liquidity, come back here. We'll take another variable call is going to be a type of object, and this information we're going to get from the contract dot slot 0, and we're going to receive a couple of things because it will have few information. So the one we need is the square price 96, and we have tick, and it is x96. That's the method we have for square price. So let's call this x, capital X, and that's information is coming from the slot 0. So once we have this one, the string information about the liquidity and the slot and tick, then we can simply come back here, take this liquidity, and we can take this JSBI, and we have to simply pass this big number and pass the liquidity, and we have to say string. Then we have to do the same thing from the square price. We'll take this big number and pass the square price 96 and convert it to a string. Liquidity and square prices looks fine. Now we can simply, we'll take a return, and we have to return a bunch of data. So we'll take this new pool, in that we can pass the token 1, the token 2, the fee amount, the square price, and we have to pass the liquidity and the tick. All of this information we are getting from this, and we are simply returning. So it will take an array. We'll pass this index called nearest usable tick, and then we can pass the tick math, and we can use this one tick min tick, and we'll call this tick spacing. This is the general convention we have to follow for performing the swap. You can go with the contract, but I just want to keep it simple so most of you can follow. And in that, we can simply pass the fee amount. Once we're done with that, now we can come back here and take the variable for liquidity as well. We'll call this liquidity net. We have the liquidity. Then we have to call this one, let's say liquidity gross. And here we have to pass this liquidity. Looks good. And I noticed one thing. So we have to take the data as a form of object. and here I have taken as an array. That's not good. So let's convert this into object, cut and paste here. And we have to take one more. So simply take this one and copy and paste here. And here we have to do the changes. So this is the liquidity. The tick spacing is going to be fine, and the amount is also going to be the fine in the index values. But here we have to do the changes in the liquidity gross and the liquidity net. So let's change this to JSB multiply. We can pass the liquidity, and we'll say JSB big int and -1. This is the setup. Looks good. Hope you guys can understand that what we have done. So we are returning all of this information. Now we can come back here and we have to simply call the, let's console log out all this information. So when this particular function will trigger, so we can identify okay, this particular internal function is got triggered. So let's take this console log and let's call calling pool dash dash. That's the only thing we have to do here. So we are getting all of this information, then we are getting the information about the token, then we are passing that information to our pool function, which will give us the address of the pool. Then we are taking that pool address to pass in the ether package to get the contract. And then on the pool contract, on the pool contract, we are calling this method to get more information about the liquidity which is there in the network, and we are providing this -1. Looks pretty fine. So that's the first internal function we have. Now we can come back here. Let's build another one. So this one we're going to call it swap option, and this one is going to be a very simple one. It will allow us to generate the options. So in that you can do a lot of customization, but I will go with the simple approach. I'll take a function called swap option. Is going to receive options. Both are fine. Once we have this option, now we can come back here and simply return. So we'll say object assign. In that we have to look for slippage, and I'm going to go with the hardcode slippage tolerance. You can simply allow user to do the customization, but I'll go with 5% slippage because that's what we follow in the industry. I'll use this method called new percentage. We have already imported that. In that I will pass with 5%. So that's the simpler tolerance I will go with for being on the safer side, so the transaction will not fail. So that's the slippage. Now I can provide the information for the recipient. So I'm going to use the same hardcode recipient address which we have taken as a test. So I'll call this recipient. Let's call this recipient, and we have to get the address and we have to simply provide here. So let's come back here. We got the tolerance, we got the slippage, the recipient. Now we can simply provide the options, and that's the only thing we have to do here in the swap option. Looks good. We're going to check all of this data, that what exactly we are returning from each one of this function. We're going to test that out and we're going to compare that as well. So this is the first one, this is the second one. Now we can come back here, and now we have to build the function to check whether the user is trying to do the swap on V2, V3 or multi, because right now we have these three: V2 Uniswap, V3 Uniswap or multi Uniswap. So that's all we're going to do the check. So it will automatically trigger that which one user is applying. So let's build that particular function called build trade. And here we're going to take a function called build trade. And here we have to simply call return new router trade. It's going to be take object. So we'll call this V2 route. We'll take this trade. And in that we're going to simply call this filter function. And we have to simply search for the trade. And it's going to take the callback function. As you all know that filter will take the callback function. In that we have to look for the instead of, and we have to look for V2 trade. And that's the only thing we have to do. That's the first thing. Once we have the information, we have to simply learn a loop. So we'll call this map trade. It's going to take a callback function. In that we have to simply call this route. V2 will take the trade route. Then we can take this input amount which is there in the trade dot input amount. Then we have to provide the output amount as well. So output amount, and there is the trade dot output amount. So this is the simple method which will give us all the relevant information about the V2 trade. What is the route, what is the input amount, and what is the output amount once you pass this particular trade. So this is for the V2. Now we have to do exactly the same thing for the V3. Copy and we have to simply paste here for the v3 as well. So paste here and change this to v3, and here we have to change this to v3, and the rest would be the same. So like change this to v3, that looks fine. Now we have to look for the multi. So let's come here, we'll type, simply copy this one and paste here, and let's do the changes. So let's call this outs, and here we have the trade, and I call it trade because it will have a lot of information. So let's call this trades S. Do the same thing here and do this here as well. So this would be fine, but here we have to do the changes. So this will be the trade, change this to mix route, and the rest would be fine. So it automatically identify that which trade we want to perform. I know it's little confusing if you are totally new to Uniswap, and if you haven't watched the project we have built in the past about the DeFi project, then it can be a little confusing. But make sure to follow the project. You will understand everything when you will perform the swap. So we are done with this. Now we can come back here and call the last method called trade type, and it will be the trades, the first one, and we can simply call this particular method trade type, and that's the only thing. Again, if there is confusion, you can simply check the documentation about the packages. Everything is explained clearly, but I would encourage you to build the project, and after that do the experiment with all this function and the method. There are tons of things that are available, but I will go with the simplest approach. So this is the entire function we have for build one. Now we're going to simply build our actual swap function. So let's come back here. Let's call this demo account, and we already have that account which we have taken. So here we have this recipient, and this account is already provided to you. So come back here in the context, and this is the account we're going to use. Copy and paste here. Now we can come back here. We'll take this swap function. Now we can start working on the swap function. So let's take a variable called swap. It's going to be an async function. In that we have to receive the information about the token 1, token 2, and we have to receive the information about the swap input amount which user wants to perform the swap. So these are the three information we're going to receive. Let's totally wrap this in a catch block, so if anything goes wrong we can simply copy that. So come here, copy this one, and that's what we can provide here. Looks fine. Now we can start working on the functionality. So first thing we have to simply console log out this calling me swap. So we can identify that we are calling the swap function. After that we can simply come here and take a variable called input amount. So I'm going with the hardcode data, so we can test. So I'll go with 1 ether. I want to do the swap. Once I have the input amount which I'm going to provide, then I'm going to take another variable called provider. So we have to get the web3 provider. We already have that, so we'll call it web3 provider. Once we have the provider, now we have to simply get the network, because this information we also need to provide in the token object of Uniswap, so it can know that which token we are interacting on which network. So we'll say await provider dot get network. Once we have the network, then we can come back here and we can simply call this ether, and this is the special function we have on the Uniswap SDK. All you have to do is to pass the chain ID which we want to connect and perform the swap. Obviously I'm not going to go with the dynamic, we're going to go with the hard code because we are doing on the ForkNet. So I'll simply replicate this and I'm going to bring it back, and let's do one thing. Let's change this to 1 because we go with the Ethereum mainnet, and let's remove this. Okay, I know, change this. So we got our chain ID object, we got our network object. Now I can come back here and we can simply get the entire contract object of each token. So we can simply pass down that information. So let's call this token contract, and we have to get both the token. So come back here, let's call this token address 1, and we already have the function called await connecting with contract, and all we have to do is to pass the address. So I'll go with this empty for time being. Let's replicate that, and this will be 2, and this will return the entire object of the token. Remember, this is the internal function we have built, in that we have names, symbols, decimal point, supply, chain ID. That's all we have there. So come back here, we're going to simply call this particular one. So we'll call this token detail. So this is the method we have. So we can take a variable called token A, and all we have to do is to call the Uniswap method. So we have this new token, and that we have to pass all the information. So first thing is going to be the token 1 chain ID. Then we have to simply replicate it and provide that to address. This will be the decimal, this will be our symbol, and this is name. So this one is for the first token, copy and paste. For the second token, change this to B, and this will be 2. Replicate it 2. In this way, we can generate the object for the Uniswap token method, which we can pass down into our function for performing the swap. Now we can come back here. Let's take a variable and we'll call this to with 2 USDC, because this is the 2 token I'm going to use for performing the swap. You can literally call anything, it's totally up to you, but this is the name I'm giving because that's the swap I'm going to do. And we'll call it V3. I'll say wait, get pool address. So this is the internal function we have built, and that we have to pass the information. So we can pass the token. So you can see this is token A, token B, that's all we have to pass. So let's call this token A, token B. Then we have to pass the amount, and this amount will go with the mid range, and we can pass the provider. So this method is there, we have the higher, but we are going with the mid range. On this particular function, we return the information about the pool, which will be available in with and that. So once we have that information, now we can simply come here and we can simply call this input amount. So in that we have to pass down the amount which we want to do the swap. So again, I'm going with the hardcore data, but when we'll deploy, we're going to make it dynamic. So we'll say ether.utils and we'll say parse ether. I'll go with 1, take it as a string, and we have to convert it for being on the safer side. So I'll go with 1 ether for swap. Once we have that, now we can come back here. We'll call it trade, await, v3, trade. We'll say form, route, and that we can simply call this new route v3. That's the method, and we have to simply pass the data as a form of array. So first one is going to be the with USD v3. Then we have to simply pass the ether, which is the chain object we have. Then we have to simply pass the token B, because that's how we're going to perform the swap from token A to token B. And we can come back here. We have to provide the currency amount, and we have to simply call this particular method called for raw amount, and that we can simply pass the ether and the input ether amount. Once we have that, now we can come back and define the trade type is going to be the exact input. This is the setup we have for the trade, and this will perform the trade. Again, we're going to see each one of this object that what we are getting when we start calling the function. But let's work on the function first. Once we have that, now once we have the trade, we can come here. Let's take a variable called router trade, and in that, what we're going to do is let's take this build function, the internal function we have build trade. In that we have to simply pass the trades. It's going to return the trade, router trade. Then we can simply come back here. We'll take this options, and we already built this particular function called swap option. In that we're going to simply pass the empty object. Again, you can pass the data like recipient, because that's what we are receiving, but I'll go with the empty approach. So if I take you here, like this is the load, this is the option we are passing, and this is the recipient you can also pass to make it dynamic. Looks fine. Now we can come back here. Let's build the params, because this params, it's very important. We have to pass down the information. So we have this method on the swap router called swap erc20 call parameters. In that we have to pass the router trade option. It will return the params. Once we have the params, now we can simply come down here and we can take the, let's say, console log out the with USDT. So all the data we'll get, let's replicate and just simply log out in our terminal. So router trade, this will be the option, this will be the params. So we can see what exactly data we are getting before we actually perform the swap. So we have that. Now we have to, let's do one thing. Let's check the balance. So let's call this ether balance, and we'll say await provider dot get balance. In that we have to simply pass the address. So we are going with this recipient because this is the test account we are using on the forknet. Now we can come back here. Let's call this let token A, token B, and we can also come back here and let's do one thing. We can take this ether balance and let's cut this one and paste here, because this one is we're going to update before the transaction and after the transaction. So let's go with this approach. Now let's get the balance of the token A. So we'll say token address balance. Now only balance, replicate this, and this will be token 2. And once we have the token A, token 2, now we can come back here and we can simply console before, and here we can simply console log out the information. So like let's console log out the ether balance, which we already have there. Let's convert that to in a format utils. We'll say ether and copy and paste here. Okay, bring it back, copy properly and paste it. So this will give us the ether balance, and we have to provide the decimal point. Now we have to do the same thing for the different, like the both the token. So let's change this to token A, and this will be token B, and this is B, this is B. Looks fine. Now we can come back here. Let's build the transaction object to perform the transaction. We'll say await signer will signer, and on that we have to simply call the method called send transaction. In that we have to simply pass the data which is available to params dot call data. Then we have to pass the to where we want to receive. Then we have to pass down the value which we already have. So I'll go with the param dot value, and we have to receive the from address which is going to be the recipient. So this is our transaction object. So I'm going to come here, copy the same address, and that's what I'm going to provide, because when the user will make the transaction, the token will return back to the user. So let's paste here. Good. So this is before, when this is the transaction will happen. Now copy and paste, and let's change this to calling me. Come back here and let's get the receipt of the transaction. We'll say receive await receive transaction dot wait. So once the transaction will complete, we have to wait for that. Once the transaction will complete, we have to simply log out the status. So I'm going to simply call this one to success, and let's change the, we'll call it status, and this information is there in the receipt dot status. Got it? Looks fine. Once we're done with this one, this is the, then we have to check for the balance one more time. So simply copy this one and come back and paste here. So we have to recheck the balance one more time. Got it? Here we have the B, copy, paste here. This will call after. And this is the entire thing we have to do for swap function, and it will work absolutely fine. Right now we cannot test this particular function on the front end because we don't have the special method, and that particular special method is only available in the hard at ether package, not in the normal ether package, which I will show you. Just wait. So that's the first thing we have. We are getting the amount. You can also get this amount from the front end, and here we have the chain ID. So when you will do on the mainnet, you can get the chain ID from this one, but here we are going with the hardcode one because we're going to test on the forknet. And here we have to provide the address of the two token which we're going to receive from the user. And here we are building all the methods, configuring, passing down the right information, and simply consoling and build the transaction object. And then we are checking for the state and whether transaction was success or not. So we're done with this all functionality. Now we have to simply return down all the function we have built so we can connect in our front end. So let's call this context provider. This is the same architecture we have followed in all the project. Let's close down that. Let's pass the children. And here we have to pass the value. So all the function we have built. So it's going to be an object type. So the first one is going to be the token swap, means our DAB name. The second one is going to be the load. token, notification error, notification success. We'll have set loader, we have loader, we have the connect wallet, and we have the address, we have the swap. So these are the function we are exporting. Looks fine. So we are done with this entire thing. Hope you guys have understood that what exactly we have done. So this is the entire swap option function we have. This is the build trade, and this is the swap function which we're going to attach in the front end so user can perform the swap. Now, to test this out, what I'm going to do is let's test this out internally, because right now we cannot connect this particular function to the front end because we don't have that particular method in our normal ether package which make any account as a signer. Right now the account I'm using, I don't have any fund in that, so that's why I cannot do the testing. But Harded give you a special method in their ether package which you can use it to connect any account as a signer, and you can perform the swap on the fork network. And that's what I'm going to do it to show you that this script is working absolutely fine. So what we can do is come back here, let's create a new folder in the main directory, and let's call this fork. Cut this one, and let's get into this particular folder. So type cd fork. Once we are here, now what we're going to do is we have to take this package like ether, like packages file, simply copy, and that's what we can simply paste here. So we got all the packages, exact packages. Now we have to create a folder. So let's create a folder called script. In that we're going to write the script. We're going to simply copy paste the same script we have built, and let's create a file inside the script folder called deploy.js, because in this script folder we can only use that hardhat special method called impersonate. So looks fine. Now we have to simply install all the packages. So let me quickly do that. We are installing all of this library, and finally we have successfully installed. You can see it took me like close to 1 minute to do the installation, and I have the entire package. Now what I'm going to do is I'm going to simply cut this one, come back to the con here, copy this one, this ABI, and that's what I'm going to simply paste here so we can do the swap. So we have the ABI, close this one, and now what I'm going to do is let's come back to the context and get this entire script. So let me quickly copy this entire and do the little bit modification, because in our hardhat we cannot use the import model, we have to go with the normal module. So finally I have copied the entire code and pasted here in the deploy.js file, and I have done the modification. Instead of import module, we are going with a regular expression. So let me show you. So here we can see, here we have the ABI which is working fine. This is the ABI we are using. We have simply copy, and that's what we have pasted here. And here this is the hardhat config file. So I have simply copied the hardhat config file and I have pasted here so we can test that on the fork network. So this is the one more thing you have to do. And here we have installed all of this library together. This is also working fine. Now let's come back to the deploy script and let me explain you. We are using the same packages, same library. All I have done, I have simply changed the import module to a normal module. So this is the swap router we have. We have the trade type, ether, token, currency amount, and percentage, which is coming from SDK code. And this is the swap router, and this is the SDK code import. Now we have this V2. We have done the same thing, trade, V2, trade. Then we are getting this V3. We are getting the pool, nearest usable tick mat, tick spacing, fee amount, and we have the trade and router 2. Then we are getting this mix route trade, and router tree. And here we are getting this pool ABI. And here we have JSBI for big number, and here we have the ABI of our contract. So this is the one we have imported. And here we are using this hardhat, and we are using this hardhat provider which allows to automatically connect with the fork network. So this is also working fine. So this is the configuration. The two state variable have added. I have imported hardhat, then I'm using hardhat to connect with the provider. And here I have taken the same ether. I've got the chain, the very first chain. Here we have that one, the chain ID. And here we have the two token. So we have the width. We have provided the chain ID, the address of the token, the decimal point, the name and the symbol. This is the second token, which is the USDC. And here we are simply calling the contract of both the token. We are passing the information. This is the width contract, and this is the USD contract. This is the exact thing we have done. And here we have this two internal function, like three internal function. So this one is the get pool, I haven't done any changes in that. It is exactly the same. We are getting all the information about the pools, and that's what we are returning right up here at the end. Close this one, and here we have the swap. Again, it's exactly the same. And here we have the build trade, and this is exactly the same. There's no changes. Got it? I hope you guys can appreciate. And so I hope you guys can understand that what are the changes you have to do. And here we have the address of the recipient. And this is the main function we have, which we're going to perform the swap. Method is only available in this particular deploy script. So we are using hard hat. We are using hard hat ether, and this is the function. We cannot call this function in our front end because the webpack is going to create a problem. So this function can only be called internally. So that's why we are calling this function inside the deploy. So this get impersonate signer. So what this function does, like you can take any account on Ethereum network and you can simply pass that account address in this and it will create the signer object. So you can simply do the fork testing on the network. Again, let me repeat what this particular function does. This particular function is not available in a regular ether package. It's only available in the hard ether package. And this particular function will convert any address and create a signer object. And this signer object, we're going to utilize it to make the transaction on the fork network as an owner of this particular address. Hope so far things are clear to all of you guys that what I have done and what I'm explaining to all of you guys. This method is not available in our front end component context. That's why we have to do is internally. Once we have the sign on, again, we are doing this exactly the same thing. We are passing the address of the two token, details of the two token and amount, which is the medium. And here we have the input amount. So let's go with 1. I was testing. So let's convert it to 1 instead of 10 ether. And here we have the trade exactly the same. Here we have the like build trade, swap options. Here we have the params, and here we are simply consoling log out that all. So I have taken this ETH balance, and here we have this WETH balance and USD balance, and that's what you have taken in our front end called token A, token B. So it's exactly the same. We are simply consoling log out the address, the balance of the token, and here we have the transaction object exactly the same, and here we have build the script. We are simply consoling log out all the object of each one of this variable type which we're going to get. Then we have again simply getting the balance and checking the balance once the transaction will complete, and after that we are simply consoling logging the balance. And this is the simple script we have to run, and this is once the transaction will complete we have to stop our application, our function to continuing. Looks fine. So far things are pretty good. No more issue we have. And if I simply copy the address and paste here, you can see this particular account has a lot of fund. So right now this account has 24 ether. That's a lot of money. And it has close to 200 tokens in this particular address. And it's quite huge. So this particular user is really very rich and has a lot of fun in that. So it looks pretty fine. And that's what we're going to test it. So I'm going to use this one. So let's perform the swap. So far things are good. Now we have to do is simply copy this one, open up your terminal, and all we have to do is to simply run this particular command. So paste here. Make sure you have to be into the fork folder, fork, F-O-R-K, fork folder, and paste and hit enter. And this is going to perform the testing on the fork network. Again, on the main network, and we are doing it on fork. So you can see the transaction went through. The transaction went through successful. So this is the balance, exact balance what we have seen on Etherscan. So this is the ETH balance we have seen. This is the WETH balance, and this is the US. This is the before balance, like 81 USD token this particular user has. But after transaction, you can see all of this data, pool details, the transaction logs which we have done, and that's there. And here we have the after the transaction is completed. So the ETH balance went down to 21, like 23. It was 24. And you can see the WETH balance is still 165, but our USD balance went up to 2,299. Earlier it was 81, but right now it's 2,229. So it went up. So let me do one thing. Let me simply comment this one. Now let's do one more transaction. So replace that and let's change the ether. So this time I want to spend 10 ether. So let's change this to 10 and let's perform the swap one more time. Hit enter and you can see our script is working fine. Here we got the balance, the previous balance before, and this is the after. So we have swap 10 ETH with USD. You can see that looks pretty beautiful. Okay, it's went up to 2228, and this looks good. I hope you guys can appreciate, and this will work for any token. All you have to do is to pass down the relevant information about the token which you want to perform the swap and provide all this relevant details which we have already built as a dynamic one in our context. So here we have already done that, and this is the exact thing we have done. So we have imported this, we have all of this imports. You have the interports, there we have this one, notification, contact, load, get pool. This is exactly the same thing, the two token, fee, amount. Then we have the swap options, bill trade, exactly the same. Here we have the recipient, and we are getting this token 1, token 2, and swap amount. And here we don't have the signer, so we cannot test this in the front end on the fork network, but it will work fine on the mainnet. So this is good, exactly the same. I have simply copy and paste the address of both the token. So this is the width and this is the USD. This is the router 10, and this looks good. This is the one we have, params, the balance of token A, token B, and here I have done the change to token A and token B. Earlier it was token A, token A, so make sure to do the change. Transaction object, this is also fine and looks good. I hope you guys can appreciate that how things are coming together. So the script we have built, the libraries we have utilized, every single thing is working fine. Looks good. Come back here and we are done with this entire context. Now what we're gonna do is we have to do the setup. So let's close this one and come back. This is the deploy script we have built. So we have already tested that. So close this one, close this fork as well. Now come back to the pages, and I have already done the configuration because I was stuck for a while when I was doing all those configuration. And here you can see this is the configuration. This is very basic. We have to import our provider and toaster, and that's what we have to simply configure. We have this provider, we have this toaster, and that's what we have to simply provide here. Got it? Now we can come back here, and now we can start working on the front end. So let's come back to the index and let's build this particular one very quickly. So let's come back, open up your terminal, simply clear it, get out of this fork folder, come to the main directory, and simply start the application on npm run dev. This is the application is running, copy, come back here, reload the page, and our application is looking fine. We have this good. Now we can come back here and let's test out our context. So let's import that very quickly. So we need this use state, use context. Then we can do the internal import. Then we say import from .just / component index. Then we can simply import all of this component, copy and paste here. That's what we have here. Let's do the import, and this one is coming from /context/context, and in that we have to receive the context, and let's receive all the function we have built. So we'll call this use context, pass the context, and come back to the context and simply copy all of this which we have exported. Copy this one and simply receive it. So let's check it out. So we have this particular variable, so it's fine. Let's call this open token. Let's take the couple of state variable, open token component. So we'll say use state. Let's call this use state. This one will be token 1. This will be token 2, and we have to change this to, this will be our open token. By default will be false. Then we can come here, let's take this input. So these are the dummy I'm taking just for testing purpose. So we'll take another one. This will be called the slippage, but in the project we will go with the hardcode data. I don't want to create any problem because sometimes the user do experiment, so that's why I'm going with the hardcode slippage. But if you want, you can provide that option. So slippage, by default I will go with 2. Then I'll go with the deadline deadline is minute is going to be like something like 10 minutes. And I can also go with the amount. So input amount, this will be input amount undefined. And let's call this output. And as an output, we're going to take output amount, and it will be undefined by default. Then we can come here and we can take this transaction. It will be undefined, and we have to get the ratio. It will be undefined, and let's make it capital. Good. So these are the variables we have taken. This is the imports, component import, context import, and we have this state variable which we have to fill out. Now we have this token swap. Copy this one, and let's test this out whether we are getting the data or not. Paste it, save it, come back here. Here we have token swap dApp. Looks pretty good. Come back here. Come back here, and here we have this. Remove this one. Now let's work on this index page, and let's do the setup very quickly. So we'll first take this pre-loader component. Inside that, we'll take this header component, and let's send the props. So we need the address. Once we have the address, then we have to take the connect function as well, the wallet connect function. Then we can come back here. Let's take the hero component. In that, we have to send a lot of props. So this one is going to be set input amount. Then we have to send this loader. Then we have to set this set open token. Then we have to take this load function. Then we have to paste this token 1, token 2. Then we have this set token 1 to set token 1. This is the set token 2 to set token 2. We have the swap. We'll say swap. These are the props we are sending in our hero component. Now we can come here. Let's call the feature. Then we have the next component is going to be a platform. Then we have the statistic. We have the security. Then we have the testimonial. Then we have the footer. Now we're going to have the dynamic components. You can see all the components are reflecting fine. We have to work a lot of components. Now we can come back here. We'll take a open token. If that's true, then we have to simply display our dynamic component. So we'll take a div, and we're going to take the class called new loader. Inside that, we're going to take our component called token, and let's send all the props. So the props is going to be the notification error. Then we have the success notification. Then we have the function as well, and the state variable as well. So we'll say set open token to set open token. Then we'll take this load token. Then we have the set token 1. Then we have this set token 2. Then we have token 1. Then we have the token 2. And we have this. Looks good. Let's turn this false. So if I come back here, you can see it's displaying fine. Now I can come back here and remove this. This looks good. Now the very first thing we're going to work on is preload component. So like this is the one we're going to work on. So let's quickly work because it's a very simple one. After that, we're going to work on the header. So let's come back here. Let's make it side by side so we can see what exactly we are working on. So this looks fine. Let's make it side by side and bring it here. And it's going to be a very small loader component. So let's take a class. It's going to be a preloader. There it is. Inside that, we're going to take a div. It will have a class called preloader dash inner. Inside that, we'll take a div. It will have a class called preloader dash icon. Inside that, we're going to take the two spans. Take the another one, and there it is. You can see our loader is working fine, and that's the only thing we have to do. So whenever the page will reload, this loader will reflect. There it is. Just reload. Here we have that one. Beautiful. So now we have to work on our header component. So let's come back here. So we're going to go very quick with our JSX, and front end component. So let's make it side by side. Close this one. Let's work on this component header. This is the hero, but we want to work on the header. So simply copy, get into the header components, and we have to receive the props. Let's replace this one and replace this one. Looks fine. We got this. Now we have to simply do the internal import. In the internal import, we have to receive the utils because we have to make an address short. So we'll receive this short address. Now we have to simply come back here. We'll take the class main menu. Inside that, we'll take a navbar. It will have a class called navbar expand large. We'll say navbar dark. Inside that, we'll take a div. It will have a class called container. Inside that, we'll take a anchor. We don't need, we have to redirect to the home page. It will have a class called navbar brand. Inside that, we'll take a remove this one, change this one, and last one is this.